All right, so what we were working on yesterday is how to solve what's called a radical equation. A radical equation is an equation that contains a radical. And, essentially what it boils down to is if we had an equation that did not have a radical, then we have a fighting chance at solving it. It might be quadratic, it might be linear. So your first step is always going to be to eliminate the radical by isolating the radical and squaring both sides. Just to stop what I'm saying for a second, is that speaker hissing right now? Okay, can you let me know if it does? Once you isolate the radical and square both sides of the equation, then you will be eliminating the radical, and then basically you're solving the equation as you would solve any equation without a radical. If it's quadratic, it's probably going to involve you factoring and setting each factor equal to 0. If it's linear, you can just rearrange it for the variable. The only catch is that when you find your solutions, you have to check them one at a time against the original equation to see if they actually work. Because sometimes for some reason, and I think some of you have figured out why it happens, but sometimes what happens is you get an answer by using legitimate mathematical steps, and that answer is just not correct because it doesn't make the original equation true. So does anybody have any questions you would like me to go over from this practice problem set? Go ahead, Seamus. 9D. So we want to solve 5 plus root n. Now, did I assign 9D? Okay. So I'm not going to solve 9D because I didn't assign it. And there's a reason I didn't assign it. At the end of today's lesson, it will be assigned. Well, that's not true. At the end of today's lesson, you're going to have some other problems assigned, but this is one that you could do after today's lesson. Any other questions? Go ahead. 7C. C? All right, so for 7C, we have the square root of q squared over 2 plus 11 is equal to q minus 1. So really, Kendra and everybody, the first step is really done. We've isolated the radical. Now what we need to do is square both sides. Of course, when I square that radical on the left, all I'm left with is the radicand, which is no longer a radicand. It's just something without a radical sign. And then when I square q minus 1, I get q squared minus 1q minus 1q plus 1. And I suspect that you, Kendra, and many other people would have just written q squared minus 2q plus 1. But don't forget that q minus 1 squared means q minus 1 multiplied by q minus 1. So that's what's going on there. I have to FOIL that. Now it's a quadratic equation. I can see q squareds. I'm not too concerned about simplifying that q and q or negative 2q. What I'm more interested in is the fact that I have a fraction. And fractions are not necessarily a bad thing. They have their uses. But when you're solving an equation, you can always multiply both sides of the equation by whatever number or thing you want to. And I'm going to choose to multiply both sides, everybody, by 2, because then when I multiply that 2 through and take 2 times q squared over 2, I won't have a fraction anymore. So I need to do this. I need to do this. I mean, you don't need to write this, of course, but I'm indicating to you the process. So q squared over 2 times 2 is just q squared. 11 times 2 is 22. Q squared times 2 is 2q squared. I'm not going to go 2 times negative q, 2 times negative q. This is negative 2q in here, times the 2 is negative 4q, and then the 2 times the 1 is 2. Now I'm getting, this is again my philosophy, you take the thing that you're looking at algebraically and you do something to it to make it algebra at a lower level. So now we don't have fractions. That's a good thing. We see that it's quadratic, so you're going to zero the equation I'm going to pick on the left side to move everything to because I have more q squareds there. So if I subtract q squared from both sides, I get q squared minus 4q, and I need to subtract 22, which gives me minus 20. Don't forget this is equal to 0. I don't think that's factorable. And what I'm doing right now is, what I was doing was I was trying to factor it, and then I thought, well, I don't think there are two numbers that multiply to give negative 20 and add to give negative 4. So that means that we're going to get radical answers, irrational numbers, that we're going to have to find through some other means. I suppose we could solve it graphically, but we always want to take an algebraic approach. So it could be that you want to solve it by completing the square. I don't think anybody does. I think you would rather use the quadratic formula. I want to go back, though. I'm a little surprised that it's not factorable. I didn't know there were some in this section that weren't. If it's not, it's still a legitimate question. We can solve it. But I want to go back and just check my work. Did I write the question down correctly? Yep. When I square the radical, it becomes q squared over 2 plus 11. And when I square q minus 1, it becomes q squared minus 2q plus 1. I multiply everything by 2. I get q squared plus 22. I get 2q squared on the other side, negative 4q. I don't see that I've done anything wrong. Looks good. So subtract q squared, subtract 22. That's what it is. It is what it is. Okay? Which is, I know is a very dismissive thing to say sometimes, but it's just the way it is. So we're going to use the quadratic formula where q will be equal to negative b plus or minus root b squared minus 4ac over 2a. So q will be equal to negative b, which is 4, plus or minus. Can you confirm, a few people, that b squared minus 4ac is 96? No. Yeah, I think 96. When you square negative 4, which is b, you get 16 minus 4 times 1 times negative 20. Yep. Root 96 all over 2a, which is 2. 96 is divisible by 4. I think it might also be divisible by 16, but 6 times. If you simplified root 96 by extracting the 4 as a 2 outside, then you would be left with 24 inside, which you would then say I can continue to extract another 4 out. Anyway, this is plus or minus root 16 root 6, which is 4 root 6 all over 2. So I'm getting for two answers 4, no I'm not, I'm getting 2 plus or minus 2 root 6. And again, I shouldn't do that. Not right at the beginning of class where we're still warming our brains up. What you're actually doing here is factoring a 2 out, or better yet, factoring a 4 out and being left with 1 plus or minus root 6. And this is over 2. And since that 4 and 2 are both factors, we can start reducing them down, and you're left with a 2 on the top, which you could multiply back in. How many of you just canceled the same number out of those three things? Probably a lot of us, right? But now we have this problem where you have to check, does q in fact equal 2 plus 2 root 6? And does q in fact equal 2 minus 2 root 6? And we can't really do this on paper. Well, I suppose we can. It's going to be a lot of work, though. Imagine going back up here. We have q squared over 2 plus 11, and then we have q minus 1. That's the original equation. So imagine putting in 2 plus 2 root 6 here, and 2 plus 2 root 6 here, and having to simplify this to see if you get that. It could be done. You know how to simplify that. But I'm suggesting, why don't we just go with the calculator? So here's my thoughts. On my calculator, 2 plus the square root of 6 is this. I want to know if that number makes the equation true. So since I'm going to be using that number for the left side and for the right side, I'm going to store that, Kendra, by hitting the store key as some number, as some letter rather, A for answer. So now I'm going to look at the left side and I'm going to take a squared divided by 2. I'm going to add 11. Then I'm going to take the square root. So when we use q equals 2 plus root 6, the left-hand side of the equation, root q squared over 2 plus 11 is 4.57. Now I'm going to try the right side by taking my answer, 2 plus root 6, and subtracting 1. It doesn't work. Which means 2 plus root 6 is extraneous. Did I not enter it correctly the first time? Oh, it's 2 plus 2 root 6. Thank you. So my A is not even entered correctly. 2 plus 2 root 6. Oh, okay. This is my A. Thank you. So I'm going to do the left side again with the proper answer, 2 plus 2 root 6, which is that number that I've stored in A. I'm going to take A squared. I'm going to divide that by 2 and add 11 to the result. Then I'm going to take the square root of the answer. So I get 5.8989. Don't try to figure out why the decimals are the same as something up there. It's a fluke. And then I'm going to take A minus 1, and I get the same answer. So 2 plus 2 root 6 is correct. I'm not going to do 2 minus 2 root 6, but you would try the same thing. I don't know if it's going to work with 2 minus 2 root 6 or not. Does it, do you think? Did anybody work it out?
In the back, it doesn't.
It says no. It's just this one. No, we could do it. I guess it'll only take a second. 2 minus 2 root 6. So I'm going to store that as A. It's my second answer. So I want to take A squared over 2 and then add the 11 to A squared over 2. I know that might look like we're dividing by 2 plus 11, but we're not. We're dividing by 2 and then we're adding 11. And then I take the square root, which gives me 3.89 something on the left-hand side. And then I'm going to take my answer, which I can see it's not going to work because this was a negative number, minus 1. I don't get the same thing. I get the negative of it, but that's not, don't say, oh, well, that's close enough. I know when my bank balance says positive $500, it's different than when it says negative $500. There's a difference between positive and negative. You're okay with that, Kendra? Okay. Any other questions from yesterday's practice? Yeah.
21.
Okay. So sometimes what happens in a math class is you're given a science equation. So what is this telling us? The time in seconds for an object to fall to the ground is related to its height above the ground. And it says that on the moon, the time can be found by taking the square root of the height over 1.8. And on the Earth, this ought to be good. On the Earth, the time can be found by taking the square root of the height over 4.9. It has to do with the fact that you have different gravitational field strengths on different planets. How many of you are taking Physics 20 right now? You learn about that. You know what this is? This is really, everybody, this equation. I don't know for those of you that have taken it. It's this equation. You drop an object from rest. Who's taking Physics 20 right now? Just a couple people. VI is 0, so it's D equals VIT plus a half AT squared. If you put in the acceleration due to gravity for Earth and multiply by a half, you get 4.9. And when you rearrange that for T, you get this equation. It's just a physics equation already rearranged for you. Anyway, the same object is dropped from the same height on both the moon and the Earth, and the difference, oh, this is a tough problem. The difference between the times is 0.5 seconds. And the question then is, what is the height? Now, I will tell you right now that I believe what's going to happen is this is going to be a question. Did I assign it, by the way? I did. This is going to be a question similar to Seamus's that you haven't actually been shown how to solve it yet. So I apologize for that. But the time it takes to fall on the moon will be more than the time it takes to fall on the Earth. So the difference is found by taking the larger time minus the smaller time. Yeah.
I understand what you're about to do now. That's not what I did at home. But what I did at home was I thought that the moon would take longer. So I took, to make t equal t, I took the square root of h over 4.9 plus 0.5. Why wouldn't that work?
It will. Okay. Okay, it will. So you understand where I was going, and I think you saw where I was going, is if you take the bigger time minus the smaller time, you get the difference. What you did is you thought of it in a slightly different way, which is still valid. You said that if I take the smaller time, that the bigger time is this, right? And it must be equal to the smaller time plus the 0.5. Was that what you said? These are the same thing. Because if I add this term right here, if I add it to both sides, I'll have root h over 1.8 equals 0.5 plus root h over 4.9. The problem here, Kendra and everybody, is that I haven't shown you how to solve this yet. Because if we were to square both sides right now, with this, we would be successful in getting rid of the radical on the left, but not the radical on the right. So I'm just going to ask you a question. We're not going to do this. I'm going to come back to this after this lesson, and we will do it. But did you do this by squaring both sides now and then seeing that you're still left with a radical and repeating the process? Okay. I will show everybody how to do this. Well, you know what? Why don't we do it right now? Why don't we get into the lesson right now? Because if you take a look at the questions here, well, I guess I didn't save it. Solve, look at this. There's two radicals. And it's not like the ones yesterday where we had radical equals radical, and if you squared both sides, it worked out well by eliminating both of those radicals to begin with. You cannot get one radical equals another radical. You've got those other terms. The same with this question and the same with this question. And since I'm going to use the question that Kendra asked about as an example, we may not do all three of these examples. So what I'm going to ask you to do is take a minute and copy down this equation somewhere. Separate sheet of paper, back of your unit handout, it doesn't matter to me. And I just want to point out to you that there's nothing really new we're learning in this lesson. We're just taking all of the skills that we have and we're propping them up to a higher level. That's all. So your goal here is to eliminate the radicals. Well, I'm going to square both sides now. And I will tell you, as well as just, taking it to the next level, what we're talking about doing here is building your skills even more. So is this something that if you are not able to do on your own, is this something that you're really going to panic over? You're going to go, oh, I'm not capable of this math? No. This is complicated. So when I square both sides, what I end up with is, on the left-hand side, h over 1.8. But on the right-hand side, let me write down what this right-hand side is actually equal to. It's equal to root h over 4.9 plus 0.5 multiplied by root h over 4.9 plus 0.5. And because this is very complicated, I don't have a problem with us keeping decimals in our work here. If we need to avoid the decimals and work with fractions at some point, we can deal with that. But in order for me to square root h over 4.9 plus 0.5, I have to FOIL out a product of binomials. So I'm going to have root h over 4.9 times root h over 4.9, which will give me h over 4.9. That's my first. My outer will be the product of the square root of h over 4.9 and 0.5, which will be 0.5 root h over 4.9. My inner is going to be the product of this term and this term, which will be another 0.5 root h over 4.5. Thank you. 4.9. And my last is the product of this and this, which is 0.25. Yeah.
Does it really matter if you do 1 over 2 just so you have fractions all in line?
No, not at all.
For 0.5?
It doesn't matter. I put 0.5 here, Seamus, because I know that 0.5 plus 0.5 is 1, so it's not going to matter. I really wanted to write, when I just said 0.5 times 0.5 is 0.25, the only reason I knew it was 0.25 is a half times a half is a quarter, and I really wanted to write a quarter. Look, it doesn't matter. We might have to make a decision here and go, well, do we want to work all with decimals or all with fractions? But that's not important right now. So cleaning this up a little bit, this is the last. I end up with h over 1.8 equals h over 4.9 plus root h over 4.9. And this is a tough problem. I get h over 4.9 as a radical because I have half of that plus half of that. And then I also have, and you know what? I am going to go 1 over 4. Now, Kendra, I just want to ask you something. You had mentioned something about you found a common denominator, right? Did you use the common denominator to put things together with the same denominator? Or did you use the common denominator to multiply everything by it to eliminate the denominators?
I used the common denominator to subtract one.
Okay. What we would be taught at earlier levels is that's what you would want to do. For example, you would find a common denominator here so that you would be able to have h over something or 5h over something. The difficulty you encountered is finding a common denominator between 1.8 and 4.9 is...
Well, I just times them by each other.
Okay, then that's what I would do. But I would do the following instead. Instead of everybody combining those terms, I would multiply, and I'm going to multiply the whole equation. I would multiply the whole equation by 1.8 and by 4.9 and by 4. And you know what I'm actually doing here? I'm saying I have those three different denominators and I really don't want any denominators. So how do I get rid of the over 1.8? I multiply everything by 1.8. This is going to be very important for the next unit. And then I have to get rid of the 4.9, I have to get rid of the 4. So follow along here carefully, and I'm trying to build your math skills. When you multiply this by this, the 1.8 cancels, and you're left with the h, and you're left with the other two numbers. So we're left with 4.9 times 4 times h. When you multiply this term by these three things, the 4.9s cancel, and you're left with the 1.8, the 4, and the h. When we multiply, I don't know how I ever taught without a highlighter, this by these three things, nothing cancels. We're not going to worry about this 4.9 under the square root. That's under the square root. That is not a coefficient that we can cancel with the other 4.9. So I have left here plus 1.8 times 4.9 times 4 times that square root. And when we multiply this quarter by these things, the 4's will cancel, and you'll be left with 1.8 times 4.9. And I realize that, this is very intimidating with all these numbers, but just think very carefully about what I'm going to tell you. I don't care what 1.8 times 4.9 is, but it's just a number. It's just a number. This 1.8 times 4.9 times 4 is just a number. 1.8 times 4 is just a number. 4 times 4.9 is just a number. So this is the first step in the problems where you have two radicals. Now what we need to do is isolate this radical so we can square both sides to get rid of it. And this is going to involve, this is a nightmare of a question. Let's multiply these together. I want to say 19.6. So you have 19.6h. I'm going to subtract this. And this is 7.2h, I think. I'm going to subtract 1.8 times 4.9. I'm beginning to regret saying, let's start with this example. We're going to power through it. But, we got all these decimals. I think we're going to end up with the quadratic formula at the very end of this as well. Because I don't think this is going to be factorable. But let's see, 1.8 multiplied by the 4.9 is 8.82. And this is going to be equal to, let's figure out what 1.8 times 4.9 times 4 is.
35.28.
Thank you. 35.28 root h over 4.9. And what's about to happen here, everybody, is it's going to get really clean and simple. Because we can take 19.6h and subtract 7.2h. 19.6 minus 7.2 is 12.4. So we get 12.4h equal or minus 8.82 equals 35.28 root h over 4.9. Boy, at the end of all this, you deserve a reward. Go out for ice cream or something. Now we're ready to square both sides. And look, you don't have to like it. It's a lot of work. When we square both sides, you have to remember that that's a binomial. Right? So this is where you kind of just come up for air, because we're about to dive back in. Some of you might think you need to divide by 35.28, but I mean, if you do, then you're going to have weird decimals here. I really don't like this question. So I need to take 12.4h minus 8.82 times 12.4h minus 8.82. Which means we're going to have a boatload of decimals. 12.4 times 12.4. So we're going to have 153.76 h squared. My outer would be the 12.4h times the negative 8.82. And this would be negative 109.368h. My inner would be the same thing, so I'm going to have two of those, which would give me negative 218.736h. And my last is the 8.82 times the 8.82. .77, no, 0.7924. By the way, what you're looking at on the left-hand side, although those decimals are really a pain, that's quadratic, right? That's nothing really that complicated. Getting here was complicated. What do I do here? Well, from grade 10, if you have two things multiplied and you're squaring them, that means you have to square each of them. Because AB squared means AB times AB. So you have an A times an A and you have a B times a B. So I have to square 35.28. And get 1244.6784. This is going to be multiplied by, I have to square the root h over 4.9, which gives me h over 4.9. We might as well divide 1240, is that 1244? 1244.6784 by 4.9, then we don't have a fraction. And hopefully the decimal we get isn't too crazy. That's not bad. 254.016. Yeah.
You divide it or multiply it?
Divide. Because the 4.9 is on the bottom. Right? So, in other words, if I say I'm going to take 1244 times h divided by 4.9, instead of saying it that way, what I could say is I'm going to take 1244 divided by 4.9 and then multiply by h. So we end up with, I'm just going to save a bit of time here, on this side 254.016h, and it's equal to this other stuff. So it's quadratic, and although the decimals are a real, like I said, a real pain, just give me 1 second. although the decimals are a real pain, we do end up with 153.76h squared minus, I'm going to have this many h's and this many h's. I have to subtract this over. So I'm going to have negative 218.76 h's, 736 h's, minus 254.016 h's, 472.452 h, and then plus the 77.7924 equals 0. I'm not going to finish this question. At this point in time, you would use the quadratic formula. I would say that going with the original equation, never mind the fact that you have to read this question and set up the equation, right? But going from the original equation, look what we did. All this was all of our work. To here, if you can do that without error, you're a master at math. Your algebra skills are on the very top, thinnest layer. You know what's interesting? I've always had that problem in the assignment booklet, and nobody's ever asked about it. I don't think I would put it in next time. You had a question, though. Why don't I square the 4.9? Why don't I square what? Gotcha. So the difference here, and this is a great question, and I would rather if all we learn today is the answer to this question, because it's so important for algebra. What Ariana is asking is, we applied FOIL on the left and we had two things and it was being squared. And on the right we have two things and it's being squared. The main difference between these two is that we are subtracting two terms on the left, but we're multiplying on the right. So to demonstrate to you that what I did is correct, if I had 12 minus 3 squared, as opposed to 12 times 3 squared, we can certainly figure out what this is equal to without algebra. 12 minus 3 is 9. 9 squared is 81. We know that whatever we do, this has to give us 81. On the other hand, 12 times 3 is 36. And 36 squared is some number that I don't know. But it's 1296. So we know that if we do this algebraically, we have to get 1296. What does squared mean? It means you take the thing and multiply it by itself, right? And you're not asking about why we FOIL here. That's the distributive property, right? You go 12 times 12. 12 times negative 3. 3 times negative 12. Negative 3 times 3. Negative 3. And you might just want to confirm to yourself that if you take 144 minus 36 plus 9, you will in fact get 81. Okay? Your question now, and I am getting to the answer, is why did we do what we did here? And the reason is 12 times 3 quantity squared means 12 times 3 times 12 times 3, which means 12 times 3 times 12 times 3. The answer to your question is, since each piece is a factor and each piece is multiplied by everything from front to back, we can put the order of these four things in any order we want. We can write 12 times 12 times 3 times 3. And the lesson to be learned here, and that's 12 squared times 3 squared. The lesson to be learned is when you are adding things together and you raise it to an exponent, you can't just throw that exponent on everything inside. It's why it would be a mistake to just take 12 squared minus 3 squared. But when you are multiplying or dividing, you can do that. Good? Okay. Let's try one more of these examples from the handout, and we'll get it to completion this time. Let's do example 1, which is not going to be nearly as harrowing, as frightening as the one that we just did, which we never even finished, the one that we just did. Not only would you have to finish that, find the solutions using the quadratic formula, you have to check for extraneous roots, which is going to be very, very difficult. We have to start here by isolating a radical. Just listen very carefully and think carefully about what I'm going to tell you. I think I want to isolate root 3x. Well, it doesn't matter. I was going to say I want to isolate root 3x because when I square both sides, it becomes something very simple, doesn't it? Okay. I don't know that it really makes a difference. I suppose we could isolate the root 5x plus 4. But if I isolate root 3x, I get root 5x plus 4, and I'll have minus 2. I get minus 2 because I have 5 on the right-hand side, and I subtract 7, which gives minus 2. So now what we're going to do is square both sides. The left-hand side, when I square it, simply becomes 3x. The right-hand side, when I square it, since it's a binomial, I have to FOIL it out. So I'm actually going to write this down. The right-hand side will be root 5x plus 4 minus 2 multiplied by root 5x plus 4 minus 2. I have to FOIL that out. I think many of you are capable of, even with something as weird looking as that, FOILing it out without writing it as two binomials multiplied. And if you can, that's fine. I don't think you have to. What you're going to get is 3x equals the root 5x plus 4 times the root 5x plus 4 is 5x plus 4. My outer will be negative 2 root 5x plus 4. How many of you would have, and I'm just curious, how many of you would have just done your outer and inner at once and put minus 4 root 5x plus 4? That's fine. I'm just doing this because not everybody would be able to track that in one step. And then my last is negative 2 times negative 2, which is plus 4. This is negative 4 root 5x plus 4. And it really doesn't matter because when you square, the negatives are going to go away, but I would still rather have the thing that we're going to isolate be positive. So what I would prefer to do is move that negative 4 root 5x plus 4 to the left-hand side of the equation, where it becomes 4 root 5x plus 4. Everything else gets collected and organized on the other side. So I have 5x minus 3x, which is 2x, and then I have plus 4. Thank you. I was just double checking that. I have a 4 in two places, so that's plus 8. Good catch. As I said, this lesson and everything we've done so far today and everything you're going to be doing today is about just getting you to be better at math. It's not all about you have to do it this way. What could we do at this point before we square both sides to make our lives a little bit easier? Isaac? Not by 4, by 2. Because I'm not a big fan of writing what I'm going to write, but I'm going to write it anyway, temporarily. If I divide both sides by 4, I would have to be able to divide the 2x by 4 and the 8 by 4. You would have to be able to cancel something out of all 3 of these. So instead of doing that, what I would do is I would say I'm going to divide both sides by 2. And I would go so far as to say I'm going to divide every term by 2. And by the way, Ariana, because this is a product of 4 times a root, I'm not going to divide that 2 into the 4 and into the root. It's just a coefficient. I divide it with a coefficient. But if it's plus, I have to divide it into each one. Very similar to the a plus b when you square it. There are different ideas here, different rules we have, depending on whether you're multiplying or adding. So if you divide both sides of this equation by 2, you end up with 2 root 5x plus 4 equals x plus 4. And now when you square both sides, don't get me wrong, you would get the right answer if you didn't divide everything by 2. But now when you square both sides, you're going to be dealing with smaller numbers, which makes the rest of the work easier. Squared, squared. So how do I square 2 times root 5x plus 4? I square the 2, and I square the root 5x plus 4. Because there's a product in here, I'm allowed to toss that squared onto each factor. I don't know. 2 squared is 4. I square the 2 and get 4, and I square the square root, and the square root goes away. On the other side, of course, I have to think of this as x plus 4 times x plus 4, which will give me x squared plus 8x plus 16. Can you check my arithmetic there just to make sure? I mean, it was just 30 seconds ago I thought 2 squared was 2, so looks good. We can expand this out and write 20x plus 16. It's quadratic, so let's zero the equation. Not often that happens. But we had 16 on each side of the equation, so when we subtract 16 from both sides, we don't have a constant term. 8x minus 20x is 12x, so I think that looks okay. How do you solve this type of quadratic equation? We can factor an x out and be left with x minus 12. That tells us that x is equal to 0 and x is equal to 12. Or is it? We have to check, right? So similar idea to yesterday, if x is equal to 0, I don't really care if you show your work here or not. What I would like you to do is put 0 in for x and figure out what the left side is, put 0 in for x, figure out what the right side is, to see if we get the same thing on the left side and the right side. I think we're going to. I think we're going to get 7 on both sides. Because on the left side we have 7 plus root 3 times 0, which is 7. Because 3 times 0 is 0, and the square root of 0 is 0. So you get 7 plus 0, you get 7. On the right-hand side we get root 5 times 0 plus 4 plus 5. Well, 5 times 0 is 0. 0 plus 4 is 4. The square root of 4 is 2. 2 plus 5 is 7. 0 works. What about 12? If I put 12 in for x, I have 3 times 12 on the left side, which is 36. The square root of 36 is 6. 6 plus the 7 is 13. Brody, can you remember 13 for me, please? Okay. When I put x equals 12 into the left side is 30. Did I say 13? Is that what you said? Okay. If I put 12 in here, I'm going to have 5 times 12, which is 60. 60 plus 4 is 64. The square root of 64 is 8. You would do this all on your calculator. So the square root of 64 is 8. 8 plus 5 is 13. And Brody, that matches, doesn't it? We said 13. So 13 would equal 13, which means in this particular case, both of these answers are correct. Are you expected to know how to solve these equations that have two radicals? Yes. Would it ever be a written response? No way. But it would be multiple choice or numerical response. And I would say on your exam there'd be one question like this. So if you're, and I'll get to your question in a second, Seamus, if you're really struggling with this, I would rather, and I'm being totally sincere, I would rather you not worry about it and you sharpen your math skills with the ones we did yesterday, which you're going to find more of on the exam, and go, you know what? I can't always get 100% on an exam, so I'm not going to worry too much about this. Some of you I know will want to get 100, so you'll want to worry about this. It's not that important, though. Okay? Seamus.
I was going to ask if on a multiple choice, like if we had to carry that on somehow, if it would matter which route we used. Like if
I get your drift. I think it would end here. I think what I would ask, and I would give you the equation, I would say the answer is something like this. And if you're really savvy and crafty about it, the answer's there, right? You can put, that's how I did a lot of math in high school, you could put 0 in and see if it works. And if it works, then you know that it's either A or C. I mean, we've gotten better at writing questions. I would not necessarily write a question that way. But if I did, then do it that way. I might instead ask, I think a numerical response is too tough. I might instead give you an equation where it ends up that there's an extraneous root. There's only one extraneous root. And I give it to you as a multiple choice and I say, what is the value of the extraneous root? Now, just because you put in a choice and it doesn't work doesn't mean it's the extraneous root, right? What I would want to see if you could do is solve it algebraically and then find out the one answer that doesn't work. But I would never give you something like this, Seamus, where we got to this point and now we're going to move on and apply it with something else. Yeah. Any other questions about that example?